In this video, I'll walk through how to set up a part for taper angle control in IGEMS, and this would be using the Apex 60 cutting head. First, we'll go and look at the machine and material settings. So under the machine settings, I've got my Apex 60 machine selected. Click on the machine icon. Under the 5-axis kinematic area, scroll down a little bit on this page. There's this button here, which normally would be set to default TAC on. So that means any part that you create in the 2D area, by default, you'll be able to apply the taper angle control to it if you want in the last step of the process. 3D 5X, slightly different, but we'll touch on that at the end here. And then we'll take a look at the material database. So we'll start with some 1/4" aluminum. Click on your material database icon, scroll down a little bit. Each thickness will have a little image down here, and this is what's used for calculating the taper angle control. And in a separate video, I'll talk about the VOC, variable offset control. So the basic idea is you're going to cut a little part like this. Doesn't have to be a particularly large part. These fingers can be 1/2 inch wide, so this entire part could be 2 inches by 2 inches. And one finger you're going to cut at the rough speed, and then one finger you'll cut at the extra fine speed, and then about halfway down each of those fingers you'll take measurements A and B, top and bottom in the rough area, top and bottom in the extra fine area. So you do want to make sure you make those measurements about halfway down the finger so that you're traveling at the actual rough or extra fine speed, versus if you take them at the corner, you're going to be traveling at whatever your cornering speed is. And once we got those values from cutting a 2D part, we'll plug the top and bottom values in here, and that'll calculate taper angle control numbers. And then we'll cut a second part with the taper angle control applied, and then we may need to come in here a third time to tweak these a little bit more depending on how close we want to get the part to be. So first we'll go ahead and make the 2D part, cut that, and then we'll come back in here and adjust that for the taper angle control numbers. So of course you can use your CAD tools, you can draw a shape like that. I've also made a parametric shape here that I could email you if you want it. Basic idea with this one, click on the image down at the bottom, prompts you to pick lower left hand corner where you want to place the part on your screen. So I'll just left click here, and then you can plug in your different dimensions for the width of the finger, height of the finger, and so on as shown in the image here. Click on OK, gives you an idea how big the part's going to be. If everything looks good, click on yes, and there's your part. You don't have to cut these holes. These are here more to make the part easier to get out of your sheet of material, so you can stick a tool or something in there to break it out of the material, since we'll tab this into the material to keep it from falling into the tank. And I'm going to move my lead in, lead out point down to the bottom middle so it doesn't interfere with any of my measurements that I'm going to be doing on this finger here. So first of all, I'll go ahead and move that lead in. So cam tab, contour. I've got a lead type for the outside set to tab, which hopefully will give me a big enough tab where this won't fall into the tank. So I'll left click down there. And now we're going to change our qualities. So we can go to our quality tool, click somewhere on the perimeter, and then I'm going to go extra fine first. I'll use my paint tool, and I'll go from this corner to the middle there, and then left click and do double click on the hole to apply that to that hole, hit enter, and then we'll do the rough, and again paint from, we'll go from midpoint to end point there, left click, enter, and then I'll double click on the hole to apply the quality there. So once we got that, click on close, set our 0 point, click on the process button. In the process area, click on the settings icon and go to strategy, and then in the top menu go down to the cutting selection. Up at the top here you have TAC, which is currently set to no but ask. So when we process our part, there'll be a little checkbox and we can determine whether we want to use the TAC or not by checking that box. So you can either set this to no but ask or yes but ask. So you got your 4 choices there. I'll leave it as no but ask for right now. And we'll just look at the code. So here's our box. So the first part we're just going to cut 2D mode. So I'm not going to check this right now. So I'd go ahead, create the code and cut this part. And as we see in this code here, there's no A's or C's. So this is just going to be a 2D part. So let's say we cut that, and now we've made our measurements, and we can go back into our material database and plug those values in. So back into the material database, scroll down, and plug in our top and bottom numbers for those two qualities. So let's say for the rough, we were 0.503 at the top and 0.528 at the bottom. And for the extra fine, we were 0.501 at the top and 0.516 at the bottom. As you plug those numbers in here, we see the anticipated taper at those different qualities. So now we can go ahead and cut this part with the taper angle control applied. So if you go back into the process area, and we go ahead and create our CNC file again, this time we would check the TAC box. And with that box checked, now we're going to have these A and C values in here, and those values will be changing as the speed changes on the part. So we would cut that TAC part. If we still find that we've got a few thou taper that we want to try to hone in a little bit more, we would go back into the material database. And if we still had, let's say, 4 thou taper on the rough, you basically add 4 thou to the bottom value of the rough. And if we still had 2 thou on the extra fine, we'd bump this up to 0.518. And again, as you change those numbers, these numbers change. And then again, you would just go back and create that CNC file with the TAC turned on and go from there. Now in the 3D 5X area, slightly different in that you have to check the box in the 3D 5X area to specifically tell it that you want to do taper angle control on a cut. Even if you check the box there at the end when we're processing to apply the TAC, if in the 3D 5X you haven't checked the TAC box for that cut, it won't apply the taper angle control. So let's go into the 3D area with this part. And I'll just put my 0, 0 point at the top of the parts. I will pick some curves, and I'll add a toolpath. I'm just going to do it for the outside for right now. So I'll just do the auto and put it down there. I've got a tab on there. In 3D 5X, we've got similar ideas as far as being able to apply your quality. So you've got your quality button here. So click on that, and we would do our extra fine again from here to here, and left click. And same thing if we want to do it on the whole, which I don't have a toolpath, so I can't do it right now, but that's okay. And then we'll do the rough again from here down to here. Left click, lock that in there, and we are done. And close. So the only difference in 3D 5X is down here at the bottom they do have this checkbox for TAC, so I need to check that and then create the part, set my 0, 0 points, click on my part button, make sure I got my Z value there, go into process and check the TAC box here, and then we've got our TAC values. So if we go back into 3D 5X with this, if I hadn't checked that box, even if I check this box here, it's not going to apply the TAC. So that's the one nuance with 3D 5X parts and the taper angle control. Now if you're doing very thick material, 4, 5, 6 inches thick, if it's going to take too long to cut apart like this, you can get the same basic data that you need by doing a couple of cuts into your material from the edge. So basically what you could do is, if we're looking down on the material, just manually do a cut a couple of inches into the material at the rough speed, and do another manual cut a couple of inches into the material at the extra fine speed. Looking at it from the side, because of the stream lag, you want to make sure that you go far enough into the material that the bottom of the stream is going far enough into the material so that you can do a valid measurement of your taper at the full speed. So you want to go, as you get thicker and thicker, you're going to have to go further and further into the material to be able to get valid numbers top and bottom at the full speed. Once you've got those two cuts, looking at it again from the other side here, you'd have these V-shapes like this, slightly exaggerated, but the rough, if you measure the kerf width on that slit, you might find it's 0.52 at the top, 0.36 at the bottom, meaning we have 16 thou difference. And then over here, theoretical values, 0.48, 0.38 for 10 thou. So then you can basically plug those differences into IGEMS and use those for the taper angle control. And I'm going to say we did that out of stainless. And it doesn't look like I have a 6-inch in there yet. So I'll add a 6-inch stainless and scroll down here. Nominal values that I plug in here aren't important, it's the difference between the values that it's looking at. So I could say the top of that kerf, again, we'll go with 500 1/2 inch at the top, and then we want that 16 thou difference in order for it to calculate the angle. So we would set this to super math skills here, 484 I believe, that looks like 16. And then similar thing, extra fine, we want 10 thou difference, and usually at the VOC, for the VOC later, we're gonna want this number to be slightly smaller than the prior number, and basically the difference between the 0.52 and the 0.48. So since there's 4 thou difference between these top numbers here, I would set this to 0.496, and then the bottom number 10 thou smaller than that. So that's easy math, that's convenient, isn't it? 486, 10 thou difference, and we've got some numbers there. So once you've got that, click on OK, and then you can go ahead and cut a little test parts, and again, if you need to, go back in there and adjust it as needed. And a couple of final notes. Of course, if you want to ever turn off taper angle control for a particular cut for a 3D 5-axis part, you can just double click on the part, bring it back into the 3D area, go to toolpath, and on this part I've got 3 toolpaths now. All 3 of them have the TAC applied, but if I decide I don't want to do it, of course I can just uncheck the box, and then the other ones will still have the TAC applied. And then we would create and update. So fairly simple for the 3D part. On a 2D part, go to the part submenu on your cam tab. You have the TAC lag button here. Click on that. It'll highlight in yellow any cuts that have the TAC applied to it. And again, if there's a cut that you don't want to apply the TAC to for any reason, in this case here, click on the off button and then click on the cut, and that'll remove that. And then the final thing to note here is, even though this open contour cut is highlighted in yellow, there will be no TAC applied to any open contour cuts. So if we look at the code, so for this open contour cut, even though that line showed up as yellow, there is no TAC applied to that. If you have any questions on any of that, please let us know. Thanks.